All right, thank you everybody for coming. Welcome to What's New in C# 11. My name's Dave. I work on the Roslyn and Razor team, and I like C#, and I like talking about it, so I'm gonna. Quick show of hands, we'll see if we can do this very quickly. Who is on C# 6 or above? Actually, let's do it this way. 6 or above? Hopefully everybody, thank you. Right, put your hands down if it's only 6. So keep your hands up if 7 or above. Okay, keep your hands up if it's 8 or above. 9, 10. Okay, so most of you seem to be on 9, maybe 10. That's cool. Perfect. Who's heard of parameter null checking? There was a bit of controversy about this feature, and so I had to include it, mainly because, so I did this talk in June in NDC Melbourne, which is where I'm from, and I submitted the talk when all of the drama was happening, and I thought, this is great, I'm going to get some good mileage out of this. And then they canned the feature, and well, the talk's boring now. But I wanted to mention it because, just a reminder, in case you didn't know, C# is open source. You can follow along on github.com/.net/C#lang if you believe that any one particular feature is the beginning of the apocalypse and the downfall of humanity as we know it, and the end of the C# language. I don't think it is. I quite like the parameter null checking feature too, but that's a whole other thing. But the fact that the team took the feedback on board and removed the feature, etc., I think that's a good sign. So if anything I show you today makes you go, ugh, maybe, join in the conversation. So what I'm going to do is I'm just going to go through every single feature of C# 11. This is actually the easiest talk I've ever done because it's the first time I'm talking about something after it's been released. And so I know what's in C# 11. In June, I had to guess. And so if you have any questions, yell out at the time or at the end, whatever, that's fine. Hopefully I'll remember to repeat the question for the recording. I'm sure someone down the front will yell at me if I don't. But let's go. Raw string literals. These are in no particular order, however, this happens to be my favorite. So, in C# 10 and below, there are 2 ways to define string literals. The one at the top is a normal string literal, I guess. It's just called a string literal. In the middle, we have a verbatim string. A verbatim string says you don't have to escape new lines, tabs, and because you escape new lines with /n, and because you don't have to escape new lines, therefore you don't have to escape slashes. I'm sure you all know this. You do have to escape quotes, though, because otherwise how does the compiler know when the string is finished? And that's okay, but it could be better. So raw string literals, the promise of the feature is you never have to escape anything. What you see is exactly what's in the string in its raw form. And so as you can see there, in the first one, we have to escape new lines. In the second one, we only have to escape quotes. And in the third one, nothing is escaped. Let's jump across to Visual Studio and write a string. So firstly, with raw string literals, they can be on one line. That's just, they can, just so you know. Or they can be on multiple lines. There's a few little quirks to them, though. So if they're on multiple lines, there has to be nothing after the first 3 quotes, and the last 3 quotes have to be on a line by themselves as well. So the delimiters have to be essentially alone. Your content is between the delimiters, not like non-inclusive. And then 3 quotes is how we delimit them. And that's kind of weird, and some people think it's a bit ugly, and I'm kind of surprised that people complained about 2 exclamation marks, but they don't complain about 3 quotes. But again, I'm not getting into that. So you don't have to escape anything, right? I can type in quotes, this is fine. I can put in tabs, new lines, / characters, no worries. But of course, that's just a spelling mistake, don't worry. Of course, how can I promise that I don't have to escape anything, right? What if I want to put in 2 talking marks? Well, that's fine. The obvious question is, what if I want to put in 3 talking marks? Now, we've broken things. So how does this work? The answer is that raw string literals, the syntax for them is at least 3 talking marks. So if you want to include 3 talking marks in your string, and if we ignore the editor trying to help me, oh God, okay. it tries to help, and anyway. So if I want to include 3 talking marks in my string, then I use 4 as my delimiter, right? You can include n talking marks by delimiting them with n plus 1. Now, the reason I'm surprised people don't complain about this is because it means this is perfectly valid C#. And you can keep going like this. And see, Visual Studio is now helping me. I dare you to go and just change every string in your code base to that, just please. We can do this. Obviously, hopefully we don't, but we can. So they're a little bit weird, but they're really, really good. The reason I love them is, so working on the Roslyn and Razor team, a lot of what I do, I write a lot of tests, because I'm a good boy, but my tests often involve, here's a chunk of code, go do something, you know, a code fix or an analyzer or whatever, and then here's what I want my code to look like. And so I can express my test data in its raw form. That's why they're called raw string literals. It's really good for that, particularly with C#. It's got braces in it, it's got new lines, it's got all these complex characters that usually cause problems. Other things this is good for is if you're testing web APIs or JSON serialization. If you've got blobs of JSON, the fact that you can grab the contents of a string, and assuming it was JSON, this would be a better example. So let's type some JSON up quickly. So I can do this. I can copy that, I can paste it into Postman, press send, and see what happens. Or I can get some result out of Postman, copy it, and paste it into my expected output. And I don't have to fight with it. I don't have to fight with the compiler. So they're really good. Now, of course, we can also do, so there's no such thing as a verbatim raw string, because that doesn't make sense, but there is interpolated raw strings. So interpolated strings with a $, same thing, $, interpolated raw strings. Of course, we now have a compile error, because we have braces in our raw string. So in a normal interpolated string, we escape the braces by putting in 2 braces. But we don't have to escape anything in raw strings, so how do we do it? Well, if you want to include up to 1 brace in your raw string, I'm glad you're all with it. This is good. It's lovely to see. So this is perfectly valid C#, and now if I want to make this a proper interpolated string, I use 2 braces, to indicate that this is an interpolation hole. And obviously I haven't defined name, so ignore the error. So again, it's like this can look a bit weird, and yes, this means that this can be perfectly valid C# as well. Anyway, hopefully no one will do this. They are really cool. So that's the fun part. Let me make this sensible and fight with the editor again. And 1, 2, 3. Okay. There is one more trick to raw string literals. Oh, actually, there's kind of 2. It's kind of 1. Anyway, I'm just going to make I'm going to make a verbatim string here. And I'm going to do the same thing. In fact, why don't I copy and paste? It'll be easier. Whoops. Okay. So these 2 strings are nominally the same, right? But they're actually not. So one of the tricks that raw string literals does, by requiring the delimiters to be on a line by themselves, they also ignore the first new line. So this verbatim string y actually starts with a new line character. And depending on what you're doing, this can throw you off, right? If you've got a really fussy JSON serializer, maybe that's an error. And so you end up doing that to get rid of that new line, but now the code looks really ugly. So the other trick they do is by ignoring that new line, it allows you to format your string data really nicely. And this becomes even more prevalent if I do this and add some indentation to the world. So this verbatim string now looks really ugly, but this is what it has to look like to get well-formatted string data into my program. With my raw string, I can actually do this. And so a raw string literal will ignore any white space that comes before whatever column the end delimiter is at. Now that sounds a bit weird and confusing, and there's probably a better way to explain it. But if you look, that vertical line that Visual Studio is drawing there, that is telling you where that string, where each line of that string starts. So you can not only get the string that you want, like the data that you want in your program with no escaping, you also get to make it look nice, which again is really handy. This is the actual reason I really love this feature, is because as I'm scrolling down a test class, seeing the code is indented nicely, and then it all goes back to line 0 for the strings, and as I'm scrolling quickly, my brain just goes, oh, that must be the start of a method, and it's not, it never is. So there's like some little tricks it does. But that's it, that's raw string literals. They're really good, they're my favorite feature. Question, thank you. Yes, good question. If I don't indent one of these lines, it's a syntax error. The compiler knows. Also, if I have mixed indentation, like if I had 2 tabs and the other line had 4 spaces or whatever it was, that's also a syntax error. So the compiler checks that what you're doing makes sense, and then you can either fix it by doing that, or fix it by putting name forward again. And I think writer also shows the vertical line as well, but I don't know. Any other questions on raw string literals before I go on to the next feature? It's really quite a weird talk because it's basically like a reference. Yes? Is it syntax highlighting this question? Yes, but that's not raw string literals. That's just Roslyn being fancy. Roslyn will detect JSON and regexes and will syntax highlight them in any string. So this works in verbatim strings as well. And in fact, you can, if it's not detecting it, you can tell it. It's like I can tell this is a regex, and it'll syntax highlight it incorrectly. but yeah, so that's just Visual Studio being fancy. I think Writer does the same as well. Can I get SQL? Roslyn doesn't support SQL, but the hope within the Roslyn team would be that the SQL team will do that. In .NET 8, James Newton King has worked on doing it for routes in ASP.NET. So routes automatically highlight with the route syntax. Yeah. Roslyn already supports C# and VB and JSON and regex. That's enough languages, I think. Right, list patterns. Who likes patterns? Because if you don't like patterns, you're not going to like list patterns either. Patterns are something that's been building up in C# since 7 point something or other. And every new version, there's another little thing and a little thing. And list patterns is the newest one to add. It's good to know about patterns in general to talk about list patterns because patterns really build on each other. So let's do this. So I can say if args is a string, well, string array, this is a pattern. It's not a very interesting one, but it is a pattern. This is a type pattern, because I'm checking the type of something. And if I go and do this, this is a property pattern. So I've got a property pattern and a type pattern. Now, obviously, this type pattern is kind of stupid because it's clearly defined as a string array, so I can get rid of that. Now I've just got a property pattern. But so patterns, they build on each other. And so list patterns is the newest one on the list. List, yep. A list pattern, the way to think about it is you're essentially writing into your code what the collection of data should look like. So in this case, this looks like an empty array declaration. Well, this is saying, is args an empty array? So if args was null, then this wouldn't pass because it's clearly, right, an empty array is a thing. I can say, well, it's strings, so I can say 1, 2, 3. So this is checking, is args, does it have 3? And the compiler will just literally do this. Does it have 3 elements in it? If it does, is the first one 1, is the second one 2, right? That's okay, that's not that interesting. But where patterns really get interesting is when you then build up onto them. So I can go in here and I can use my length again, and I can say length 4. So this is saying, is args got 3 elements in it? First element is 1, last element's 3, and the second element is at least, well, no, not at least, is 4 characters long. I can do is least, at least, by saying that one. Anyway, maths is hard. But again, this is a relational pattern inside a property pattern inside a list pattern. So patterns, list patterns, great, but they can be a bit weird to understand. Personally for me, and I've been using C# 11 since C# 10 was released because we're on nightly builds, I'm at the point now where even still, I don't write list patterns from the get-go, but I write a bit of code and then I read it and go, oh, that could be a list pattern. And that's sort of taken me a while to get to. It used to be that I would only notice it a week later that I could convert to a pattern. It takes time to sort of build in, because I think we've just got lots of muscle memory about writing if statements. The other thing you can do with list patterns is use the range operator, I guess. And so what this says is, does list have at least 2 elements? First one is 1, last one is 3, and any number from 0 to n in the middle. We can also capture things from them with patterns. I'm hoping that just says it's not used. Yes, good. Whoops. So this is saying, are there 3 elements? Is the first one 1, is the last one 3? And no matter what the second one is, put it in the variable s, and then I can go and use s. I've used this sort of thing for like path parsing. So you go string.split, and then a list pattern to say, well, is it program files, Microsoft, whatever, and then what I'm looking for, you know? And then the other thing, oh, and so discards also work, I should say. And again, that's just another pattern. Let me jump over to SharpLab, and I will show you what's going on here. So if I write this code here, let's go with 1 ... oops, and 3. So if you haven't seen it, this is sharplab.io. What this does is it compiles your code with the latest Roslyn, and then it tells ILSpy to decompile your code as though it was written in C#1. So it basically unwinds all the syntactic sugar. And so this is why I love patterns, because all of that code I didn't have to write. So you can see we get the length, we do the length check, check the first element, check the last element. This is what the compiler is doing. Now the compiler doing this is not just saving you time, it's also doing, the compiler understands your patterns. So if this was a switch expression, it's doing exhaustiveness checks. So let's go, I don't even know. Switch. Typing is hard. True, that'll do. That's a thing. Okay, what have I done? Did I compile? No. What have I done? I can't read my own writing. Type or namespace definition. What? Oh, I've missed a brace, haven't I? Too many braces. Well, just keeping you on your toes. I knew what I was doing. All right. So this is the same pattern I had before, but in a switch expression. But so now if I go 1 ... oops. False, doesn't matter. So this is cool, but the compiler knows that we haven't handled all possible cases. So that's potentially useful. If I move this up 1, if I'm understanding my own code properly, did SharpLab just die? Anyway, what should happen there is it should flag the second one as being unreachable. There we go. The pattern is unreachable. So SharpLab died for a bit, never mind. So now it's saying this pattern is unreachable. So it knows, it understands what you're doing because, well, because it's a compiler. The downside of patterns is they have to be compile time, they have to be evaluated at compile time so that the compiler can do this. That can be a downside sometimes, because if I had, like let's say I had another argument here, I can't, oh, I guess that would have to be a string. I can't do this. Oops. So this doesn't work because number is not known at compile time. So that can sometimes be annoying, but it's because of the extra protection the compiler is giving you by knowing about what you're doing and whether what you're doing is redundant, etc. So list patterns are just another sort of arrow in the quiver of patterns, but they are really useful. The other thing is, like this is a string array, but I could easily make this a list. I could make this a collection, you know, like the compiler knows about the standard sort of collection-ish things, which is good. The other thing, one other interesting thing I can do is I can say that, no. I think, wait a minute. This is where I have forgotten what I was going to show, and I've got it wrong. Oh, that's because it's X, right. Now what? Unexpected character. What? Oh, maybe. Sometimes SharpLab also gets confused and thinks I've got characters I don't have. There we go. See, it was worked. So now what this is doing is this is saying at least one element, because dot dot can match 0, and then any number after that, but capture that into another sub-array. So that can be really useful to pull things out, and you can pull things out in the middle as well. So I could, I can do this. So it can be really powerful. You can only have one range operator in a pattern, in a list pattern, so you can't put two of them in, and like it doesn't do like wildcard matching. But this can be really useful. The trick with this, or the thing to watch out for with this, is if I change this back to a list. So this now is not compiling because it doesn't know how to pull out the middle of a list into something. Arrays it knows, spans it knows, but lists it essentially doesn't know. It does know, it just doesn't want to allocate memory to do it. That's list patterns. Any questions on list patterns? That's cool if you think of one later, no worries. Ooh, 20 minutes. All right, UTF-8 string literals. I'm gonna have to speed up a bit here. This one is relatively niche. If you need this, then it's great, and if you don't need it, then you'll never need it. Essentially, if you have any code in your applications, in your programs that deal with byte arrays, or that deal with UTF-8 strings, this is useful for you. So what this is, it says UTF-8 string literals, but I don't like to think about it this way because it's not really a string. If I go var x equals ABC, so the U8 thing on the end is how you denote this as being a UTF-8 string, just like you do M for decimal and F for float. But what this is, if I hold my mouse over var, which, well, you might not be able to see it because you can't zoom in, it's not a string. It's a read-only span of bytes. And that's what makes this a little bit niche. And if I go to array, then it's a byte array. So it's not a string. You can't do string operations on it. This is a handy way of writing byte arrays. So if you do lots of processing of UTF-8 strings, UTF-8 files, and you process them as byte arrays, and if you've got checks for, is this equal this, if you do a normal string check on it, then it's not as performant as it could be because strings in .NET are UTF-16. So if you want performance, you compare them against byte arrays, but if you compare them against byte arrays, you then have magic numbers in your code that don't look good. So UTF-8 strings, string literals, are a way to avoid that. But as I say, if you don't do that, you'll probably never use them. Required members. Okay, this one I will take a few more minutes with. Let me write a person class, because that's what you have to do demos with. And I'm going to write a first name property. Let's go with, no, let's do, setable is good. And I will go middle name and last name. So here's my person class. It's the same person class we all make, that we definitely all have. And we have warnings. We have nullability warnings because I haven't provided a value. I've said these properties are strings, not nullable strings, and therefore I have to provide a value. This is really annoying because I don't want to provide a value. I'm just creating a class. I want whoever creates my person to provide a value. And so I can do that by saying that this is read-only. What this is doing is this is telling the compiler first name, middle name, last name, they have to have a value. They can't be null, and they have to have that value set when the person class is created. This is presumably complaining read-only. What did I say? Required. Thank you. Ah, dear. There we go. So now, if I go up here and I go create a new person, now the compiler is complaining, but it's not compiling at me, it's complaining at whoever is creating my person class, which is exactly what I want, because I'm just creating a DTO. And I can come here and I can say, I can specify a first name, and then, obviously this is a terrible person API. We don't want middle names to be required. I don't have a middle name, and not everybody has a last name either. So now everyone's happy. I've defined my DTO how I want, except for the semicolon, and my consumers know what I expect. Now, I think about this feature in terms of fixing this hole in nullability, but it's actually strictly unrelated. So if I make last name required again, because no, not everybody has a last name, but for my target audience of mainly Western people, most of them do, I still want the consumer of this class to think about the last name. So it's still nullable. I don't have to set it to a value, or I mean I do, it's just that null is a valid value. So it fills a gap in nullability, but don't conflate them necessarily, that's just me. What this is really in aid of is the style of C# programming that is not using constructors. So object initializers like I have here, they're getting a bit more popular now. We have records with syntax and anonymous types and all these things. There's other ways to construct things. And so this is a way to say, you know, in the old days, or the current days, you create a constructor and you put on the parameters that are required to be set, and you can't construct the class without calling the constructor. This is a way to say, well, you can be more flexible in how people create the class, but you still can denote what is required, what isn't. Speaking of which, if I create a constructor, let's create one that takes a first name, and we need an empty one so that my code above doesn't error. So this is cool, and if I create a new person, another person, we have a problem. And the problem is this says, you haven't set any required properties. When in fact I have. In fact, if I take required off last name, I've set all the required properties. So this problem is one that sometimes emerges from the compiler. In general, the compiler doesn't inspect the code inside a method to see what it's doing. And the reason for that is it gets very complicated because your method could call other methods, it could hit a database, it could call a web service. The halting problem is a thing. So generally speaking, with nullability, with required, lots of features, it doesn't look inside the method. So the way we sort of get around this is there's an attribute called sets required members. And what this says is, if someone calls this constructor, don't complain about required members of them. Now you'll note that that constructor does not set the required members. So that's me telling the compiler, hey, don't worry, I've got this. If I don't have this, that's on me. But it does mean that both styles can live together in the same code. You can have constructors and you can have empty constructors, but you can still denote what do you want to be nullable, what has to be required, what's settable, like we've got init properties to say they can only be set once, all these things. So it's just about more expressiveness in your details. Any questions? Cool. Static abstract interface members. Right. This one's a little weird because static members on interfaces exist already, but they don't work this way. So there's abstract as a keyword to denote which one you want, but abstract is kind of redundant on interfaces. But anyway, what this does is it lets you define a method on an interface and say that it's static. And then just like every other method on an interface, normally, anyone implementing that interface has to implement that member. And they have to implement it as a static member. So in this case, we have a property called canWalk on iAnimal. So anything that implements iAnimal has to have a static property called canWalk. That's the compiler feature. It's not super exciting. Where this comes in, or where this is useful, is with generics. Because in my class down the bottom here, I've got a generic class, and I know that T has to be something of this interface, but I don't know what. That's the whole point of generics. That's why I'm using it. So I can't call dog.canWalk, because I don't know it's a dog. And if I could call dog.canWalk, then I didn't need the interface. So this lets me call a static method or property on a generic type, knowing that it implements the interface. So where this is really cool, there's two things this is really cool for. So number one, I'm going to create an interface called iAsync factory, and I'm going to make it generic. And I'm going to put a static abstract task t self create async method. So what this means is, I can spell, I swear. Who decided to spell check when VS was a good idea? I'm going to create a class called goo, because I like the word goo. It's, iAsync factory of myself. I implement it, I get a static method. So this is, this isn't very exciting. Like the generics maybe look confusing, but this is just a static method that implements an interface member. But what this means is, there's no such thing as async constructors in C#. I just made them. If I have some kind of method that I want to be able to construct instances of things, then I can make that method, take in a t, and I can say where t is an async factory, and now I know that there's a create method I can call that will asynchronously, whatever that means, create an instance of that class. What it actually means, it's up to like, I don't know, wait task.delay, like that's, there you go. I think this is really cool for this sort of thing because this is something we couldn't really do in C# before. You could say a generic type had to have an empty constructor, so it had to be able to create it, but only empty, right? Not with, well, it couldn't be async, couldn't have any properties, whatever. The other thing you could do here is just allow, have parameters. So maybe I say that I want everything in my whole system to be constructed. You have to take an iLogger, because I want logging to be really important. So, have this static method here have a parameter on it, and then everything that implements it has to have that parameter. So this is a way to, well, in the past I would have done this by having this interface, and I would have had this create be a normal method, not a static method. And so you'd pass in an instance of the thing, and it would call the method, and it really should have been static, but it just couldn't. This now allows for that. The other place this is interesting that you possibly have heard of is generic math. So this is a new feature of the .NET runtime that takes advantage of this feature. So I can make, what are we doing? We'll do the classic add method. Oops, I forgot. I'm going to make an adder. No, wait, no, I'm not. I'm just going to make a method. So add, we're going to add two integers together. Great. No worries. I can call add. Whoops, apparently I can't. Okay, that's not very exciting. But of course, this only works for integers. If I want to work for other types, that's where generics come in. But, whoops. But with generics, I can't add them together because what does that mean? So it turns out in C#, what you write as a plus operator is actually a static method. And it's a static method called op_addition. And so if I say where t is an I number of t, now my code compiles. The reason for this is I number is an interface that says you must have a static method called op_addition, and the integer class, in32 class, implements that. And in fact, if we look in iNumber, it's actually not implementing much. That's weird. Oh, right, iNumber base, apparently. There we go, there's the list. There's a lot of interfaces. I_addition operators is the one I want. And this, here it is, here's the operator. So the int32 class implements iNumber, which in turn implements this method, which means the compiler is now happy for me to say a plus b on this generic type of t, which I have no idea what it is, but I know that it at least has to support iNumber. Where this comes in more useful is things like, where is this? iSpan parsable, probably, yep. So iParsable is an interesting one for me. This is a new interface in .NET, and various types will implement this, and what this says is, whatever type it is has to be able to be parsed from a string. And I can think of a number of times in the past where I would have wanted this behavior in some generic method, like a deserialization method is a perfect example. Deserialize this string as this type. Well, if that type has a parse method, you don't have to write any code, right? Whoever wrote the type's written it for you. So there's a couple of aspects to this. You can write your own interfaces and you can now have static methods on them, that's good. You can take advantage of iNumber and you can do generic math, and if you've got math-heavy code, then that'll be really useful. But also there's lots of other interfaces in .NET that you can just explore. And a lot of the inbuilt types will support them. So iFormatable, well, iFormatable existed, but there's now an iFormatable that actually has static methods that mean things. Any questions on static abstract members or generic math? Not that I'm very good at math. Cool. Generic attributes. There's not much to demo about this one. It's pretty much what you see on the screen. In the past, you would always have to use type of for attributes, and then you had a type, and then you had to do something with that type. And that can be annoying. And now attributes support generics. So now, in my second attribute there, the generic attribute, instead of having a type that I have to play with, I have a T. And because of all of the other things that generics allow, but for example, static abstract members might be one of them, I can possibly do things with that T without having to go, activator.create instance or using reflection to get properties, etc. There's not, as far as I know, there aren't any generic attributes in the BCL yet. This is just for things to take advantage of. Order default structs. Who does stuff with structs? Anyone much? Just you? Okay, I don't. I've managed to avoid structs. But it's actually why I like this feature, because I don't use structs enough that I forget the rules, and this feature, as well as one from C#10, makes the rules more like the same rules as having a class. So, order default structs. In C#9, having this empty constructor would have been a compile error. You weren't allowed to create a parameterless constructor for structs. The compiler creates one for you, and that's it. In C#10, that restriction was relaxed, and now you can create one. But in C#10, if I create a field, in C#10, when I call this, no, sorry, in C#10 this would have been a compile error. Right, now it's not a compile error. It's very confusing. Because what happens is, if we scroll down here, we can see what the compiler is doing. The compiler will now synthesize a setter, essentially, so setting the field, setting the property, whatever it is. It'll synthesize that into your code, into your constructors, to initialize any field or property to its default values. So this is exactly how classes work. The difference is that in a class, the compiler doesn't actually have to do the work, because when the class is allocated on the heap, the runtime clears out the memory for you, right? That's how classes work. Structs get allocated on the stack. They don't clear memory, so the compiler has to actually write the code that says x equals 0. But yeah, so what this means is that structs just act essentially, they don't act like classes, but the rules for creating them and writing them are now much more aligned, which is good because I can never remember them. What is worth noting here, if you do use structs, is the difference between empty constructor versus default versus a real constructor. And I mean, if I delete this, you can sort of see what's going on here. So without an empty constructor, the first struct we create, which calls the empty constructor, is the same as default. If I put my constructor in, it now does something different. So this came in C#10, but it's worth calling out that there could be a difference between, if I just go like that. So there is now a difference between an empty constructor and a default of this struct. And that could be a trap, but again, it's kind of what the author of the struct intended, so it's maybe not a trap, but worth noting. All right, we're going okay for time. This is the last full slide, but I didn't set the number of features in C#11, so the talk only goes for as long as they did work. Ref fields and ref scoped. In the past, I've said this is a niche feature, and then people complained that it's not niche because they use it all the time. That's fair. I don't use this, and I don't know if anyone in this room will. It's the kind of feature where if you need it, you probably already know about it and don't need to come to this talk, but I'm going to try my best to explain it. Structs are weird. That's my explanation. So structs get allocated on the stack, and there's a certain type of struct called a ref struct, which gets allocated on the stack, but it also can never be on the heap. It's a rule. That's what the ref means. And span is one of those. So I can't have this span field on my struct. Even though my struct is going to get allocated on the stack, and a span has to live on the stack, I can't have the field there because what if my struct gets boxed and gets put on the heap or is part of an async method and gets shoved off to the side and wakes up 3 seconds later or whatever else. So the rule says you can't have what's called a ref struct, which is what span is. You can't have a ref struct on a struct. You can have a ref struct on a ref struct. So I can say that my struct is now a ref struct, so it can only live on the heap, the stack, whoops, and therefore it can contain things that can only live on the stack. And so the compiler can verify all of this by me declaring what the rules are for my thing. That implies the rules for the things I hold. But now we have another error up here which we didn't have before. I can't pass this parameter to this method on a ref struct because that could allow that parameter, which is owned by the caller method, could allow it to leak out. Right? This struct could do something with it that would be bad. And we can't have things on the stack leaking because when the method that called it, well, when the method itself or the method that calls it goes out of scope, that memory is used for something else. So we can't have anything leaking. So the new feature here is that I can say this is scoped, and now my code compiles. And I can tell from your faces you're just as excited about this as I am. What this is doing is essentially there's new ways, well the scoped keyword is another way to tell the compiler essentially what you're doing. But it's you promising to the compiler that you won't do bad things, but it also allows the compiler to verify that you won't do bad things. So scoped, this parameter is scoped, so I can use it in this method. If I tried to pass it to another method, that would be a compiler unless that method was scoped. And so it's got to be scoped all the way down. It's got to be ref structs all the way up, right? So the rules are kind of straightforward, but by building on top of that rule system, the compiler essentially can trust that you're doing the right thing. So again, if you know about refs and structs and scoped and whatever, great. And if you don't, even better, because I don't either. You can do read-only ref, or ref read-only, or read-only ref read-only, and they all mean different things. And I'm so glad I don't talk about it. All right, this is the last slide. So if you have any questions, if you've been holding back, this is the grab bag of features. We're at 42 minutes, which is fine. I don't mind. I can finish early. These are just small things. And in fact, I'm going to go from the bottom up just to make it quicker. So numeric int pointer is not very interesting. There are data types in .NET called nint and nuint. Actually, I'm going to type because this one's funny. So there's nint, right, which is native integer, and then there's native unsigned int. And every single time I type it, I type nunit, and it really confuses me. In C# 10 and below, these were weird things that would be represented by the int pointer class, so the int pointer and uint pointer. These would be represented by this class, but the compiler allowed you to do a little bit more with them. It was a bit weird. So now in C# 11, they're just aliases in exactly the same way that int is int32 and string is string. There's things. Again, if you don't use them, then you don't think. Pattern matching span of char is useful if you use spans. So if you don't know what a span is, or a span or a read-only span is a way of essentially saying that you want to work on the memory that represents a bunch of characters, but doesn't have to be a string, right? It could be a file, could be something else. Or if it is a string, it's a way of dealing with it without essentially saving memory allocations. That's what span's for. So span of char specifically is very commonly used to point to strings, but you couldn't do if statements. So if you had a span of chars, you say, well, I don't care what the backing memory is for this string, essentially. I couldn't even check if it equals something else. And so you now can. We know how to do pattern matching on spans of chars. File local types are maybe interesting. So this is being able to put the file keyword in front of a class. And so this, let me go static int, I don't know. There's a method. So I can go c.goo. But if I create a new file, oh God. Okay, let me do this again. Add class. If I create a new file, see, it doesn't work. So a file scope class is exactly what it sounds like. That class C that I created there is only valid in this file. And in fact, I can create another one over here, and it'll work in this file. Oh, whoops. There we go. Of course it does. What have I done? Oh, it helps to be in a method, honestly. So used to writing shorthand code, I forget you need to put things in. Anyway, so I can have multiple classes with the same name in different files, and they're scoped differently. And in fact, if I jump across to SharpLab, oops, copy, you can see, did SharpLab die again? Poor SharpLab. I've seen it demoed in at least 3 talks today, so it could just be, come on SharpLab. Okay, yeah, check that class name out. So a little bit of compiler magic to make it unique. It's actually a hash of the file name, so it's not random, it's deterministic and things work. They're mainly useful for source generators, if you're into source generators, because you don't have to worry about class names clashing. If you say this is only valid in this file, you'll never have a problem. Name of parameter in attributes, that's pretty simple. So int x, and I can say description and template string, name of x. Hello. Yep, talking marks. And that should be a brace. That should be a bracket. There we go. This didn't use to compile. In C#10, this would say, I don't know what x is, and obviously what you meant was the parameter, and so now we allow that. That is very useful and comes up reasonably often, but probably not that you can name right now. New lines in interpolation holes is fantastic. I can do that. That's the entire feature. I can put new lines in. It's actually very useful. It's just kind of, didn't deserve a whole slide. All right, and last one, 45 minutes. It's all on you if this is going to take an hour. It's all up to you. You've got to ask questions. This one's good. So this one is a perf improvement that lots of people do, but it's a readability detriment. And so in C#11, we can now get the perf benefit without the readability detriment. So what this is about capturing method groups. So I have these 2 lambdas here. One I have written as a full lambda, and one I have just written as the method name because the method signature already matches the lambda. Excuse me. And if I scroll down to what this compiles down to, it's these 2 lines. And it's a bit hard to read because the C# compiler generates these types with crazy characters. But what this is doing, so for the full lambda syntax, the first one, this says, oh, well, hang on. There's a type called C, which is this class, helper class. And there's a field on it called 9__0, this one. And that field holds a reference to the lambda. And so this says, use that field, it's a static field, if it's not null. And if it is null, then we initialize it to a new lambda. That's caching in order to avoid an allocation, right? So we only create this lambda in memory once. The second line, where we just use the method name, is just saying, yeah, it's a new action. This is allocating memory every single time this is called. And for the wrong bit of code in the wrong spot, this could be a problem. And so you go through and you make all of these things actual lambdas, and it makes your code a little bit more ugly. It's not a huge difference when I'm creating fields, but if you're passing lambdas into methods, it's really nice to just see the name of the method that's going to do the work than a lambda. So what needed to change here, interestingly enough, was the C# spec, which had a line in it that said something about, you can't cache lambda delegates, and now it says you sometimes can. That was a change. But so if I make this static, we get this new compiler behavior. And there's all sorts of reasons why it doesn't do it for non-statics, and I'm not going to go into. But if I made that method static, we can now see these 2 lines essentially do the same thing. The names are different, it's a bit quirky, but this is now only allocating once, and so your performance is better, but it's also still more readable. And that is the end of the talk, because that's all they did in C#11. And unless you want me to talk 10 minutes about what's in C#12, but I don't know yet, because it's really early. Is there any questions about anything? Or you can go get a coffee, or you can go get dinner. Not dinner, I don't know. It's 2 a.m. where I'm from. Hello, question.
Also, the static abstract interface members, what are the implications if you declared a variable that you've actually got something of a subtype of that variable? So if I've got cat inherits from animal, and they've got different implementations of the static method.
Okay, so what are the implications if you have different implementations of the static method with different instances of the interface? Yeah. So this is maybe one of the weird things about static interfaces. So if I have an interface called this, and I say static void that, versus saying static abstract, oops, void, I guess I should probably give it a different name. So interfaces could have static methods before, and you called them by just doing igoo.goo, because they were just static methods on a type. An interface is a type. Class is a type, a struct is a type. And what you could then do, so I could go class, I don't know, animal, I'm mixing my metaphors now. I can do this, and I can implement this interface, and I can say animal.goo, whoops. Maybe I can't. Okay, I can't. You can do that with base classes, and so maybe, I thought that's maybe where you're going. So the answer to the question, though, is kind of, there isn't a problem, because if there was, it would already exist with interfaces. So if I have a variable of type animal, then I can't call that static method on it. Like, it's a static method. You have to call it on the type. So if you're worried about getting a cat but calling the method on dog, you would have to literally type in dog.goo, and in that case, well, you're calling it on dog. There's no ambiguity. So it's a bit weird, and I understand why the question, because this seems odd at first, but they really are only useful with generics. You wouldn't expect to have a strongly typed variable or local that you would use these with. Because if it was strongly typed, you wouldn't worry about the interface. I don't know if that makes any sense. I got confused halfway through. Any other questions? Yes, up the back.
Why do people hate the argument null check stuff so much?
Okay, cool. We've got 7 minutes. Let's talk about argument null checks. String, so string G, that. Why did people hate this? I love this. I did a PR so I work on the Razor editor mainly, and I did a PR into that removed about 2,000 lines of code just by putting in exclamation marks. And I then had to remove it, which was really annoying, because I couldn't just git revert because we'd done a bunch of work. Anyway, don't be an early adopter. People didn't like this for a couple of reasons. Number one reason, they just didn't like the syntax. They just thought it looks a bit angry. I don't know. I don't mean to make fun, because they had valid concerns. I just don't know. There's a lot of people who wanted it on the type. So they kind of, if you think about nullable is on the type, the question mark would be on the type. So it makes sense to say not null is on the type. But that kind of falls down in a few scenarios where it doesn't make sense. People, I think, I quite like that, if you want the null, the exclamation mark is the null suppression thing, right? Where if you've got a nullable thing and you say, you go, null. It's like, yeah, it's not null, trust me. I kind of like that it was an extension of that, whereas like 1 exclamation mark tells the compiler to shut up about nulls. 2 exclamation mark tells the runtime. Like, I kind of like that, but it's also a bit different, because one tells the compiler to stop complaining, and the other one tells the runtime to throw an exception, which is actively complaining. So those sorts of reasons, there's a very long thread on C# Lang, and I promise you, and again, I don't mean to make fun, but I promise you, every single thought you're having now about why this is good or bad has been discussed in that thread, which is a good thing. It's very thorough, there's lots of engagement with the community. At the end of the day, the biggest problem with C# with this sort of thing is that C# is 20 years old and it is 100% backwards compatible. And so any new syntax that goes in now, it's there forever, it has to be supported forever, and you can't use that syntax for other things. So let's say null suppression maybe gets some new way to work, maybe the logical thing would be to put 2 exclamation marks on, but we can't because that means something. So it's very hard to introduce new syntax. It's very, I guess it's sort of risky in a way because you are really committing yourself. So if the versioning of C# was a bit more lax and we weren't so backwards compatible and we weren't really tied to this forever, I think we might have seen a different result. But it is hard to put in new syntax that isn't, it's not a slam dunk. Which actually brings up another thing. I wonder if I can demo this. Let's try. This is another interesting, this is kind of a compiler feature, but it's not a language feature, so I didn't include it, but it's relevant here. One of the things that was going to be in C# 11 was the field keyword, but you could have a type called field or a field called field, and that could cause conflicts. Conflicts is something the C# compiler team, or the language team, has to deal with all the time. If you want a new keyword in the language, like record or like scoped or whatever, you've got to think about, well, what's going to happen if someone has a type called record or a type called scoped or a field called or a parameter or whatever? What are the rules? What's going to win? What are we going to resolve this to? And so one thing that is new in C# 11, the compiler, is that it will now warn if you have any classes defined with lowercase names. Because the problem of trying to work out new syntax to add is getting so difficult that we kind of need to stop people from taking all of the good words. So things like that is why it's a big ask to put in new syntax. And so it's not just that people didn't like the syntax, it's that if we put it in, it would be there forever, and we'd have to support it forever, and we couldn't use it for anything else. And if there's no more questions, then I will let you escape the room. Thank you very much.